In this lesson, we will learn the electron configuration of ions and how we will write the electron configuration using the noble gas notation, which is the shorthand representation. There is no big difference in writing the electron configuration of ions. We are following the same method as we wrote for other elements, the neutral atoms. Only difference is in the number of electrons in an ion should be calculated before we start writing the configuration. When we write the electron configuration of a positive ion, we remove one electron from each that corresponds to each charge. For example, sodium. This is a neutral atom and this is the sodium ion. So sodium ion has one positive charge. So we will subtract 1 from the total number of electrons of sodium. Sodium has 11 electrons. So when you write the configuration for Na+, we will write the configuration for 11 minus 1, 10 electrons. So there are 10 electrons in the sodium ion. So for sodium atom, we are writing 1s2, 2s2, 2p6, 3s1. Whereas for sodium ion, we will just write 1s2, 2s2, 2p6. We will not write 3s1. We are removing that electron. That process is because the neutral atom is changing to a positive ion, a cation, by removing one electron. So no big difference, only the calculation of electrons. Okay, so then we will see another example for oxygen. So here what's the difference is oxygen, neutral atom here, and oxygen will gain 2 electron in order to form a negative ion, which is an anion. And how to write the configuration for the neutral atom? We have 8 electrons, so we will write 1s2, 2s2, 2p4, right? Whereas in the case of ion, we had to remove 2 electrons. We had to add 2 electrons because it's a negative ion. So we are taking 2 electrons. So 8 plus 2, 10 electrons. So 1s2, 2s2, 2p6. We are adding those 2 electrons to the p orbital. And here we are taking off 1 electron from the 3s orbital, which is the highest energy. So we have to take off the electron from the highest energy level. So let me summarize these important points here. So remember, positive ions, which are cations, which are formed by removing electron from the atom. Negative ions are formed by adding electron to the atom. Electrons are removed first from the highest occupied orbitals. Okay, these are the 3 points we have to remember while writing the configuration for ions. So the example is here. So for sodium, we already discussed 3s1 is the highest energy level. So we are removing that electron. And for chlorine, we are adding 1 electron to the highest energy level. So it will be 3p6. And now for the transition metal, let me give you an example of iron. For iron, the atomic number is 26. There are 26 electrons. So when you write the configuration, you will get 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2 and 3d6. And now when you write Fe2 plus ion, as you know, we had to remove 2 electrons. So 26 minus 2 will be 24. So how to write that one? For getting 24, 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. We are removing the 2 electron from the highest energy level, which is the 4. See that 3, this is the lowest energy level, third shell, and we are removing from the fourth shell. That is what it means. So you cannot take off electron from the 3d. You have to take off from the highest energy level 4s. That is what it means. And now we can predict the charge on the ion of an element from its position on the periodic table as well. All the first group will have +1 charge, second group +2 charge, 13th group, mainly we are dealing with aluminum, so it is only aluminum is shown here, +3, and 14th, tin and lead, 4+, 14th group, and 15th, onwards it's going to be negative because non-metals. So nitrogen will have -3, phosphorus also will have -3, and 16th all will have -2, 17th all will have -1. We don't talk about noble gases because no ions formed. So electron configuration of ions, let us practice. Okay, for magnesium, how to write, and how to write for chlorine we already discussed. How to write for positive ion and negative ion, we will follow the same method. So what is common feature that you observed in all these ions configuration? You see that how many electrons are in magnesium 2 plus, 12 minus 2, 10. So you have to fill only for 10 electrons, not for 12. So we have 1s2, 2s2, 2p6. And now let's see for chlorine. Chloride ion, 1s2, 2s2, 2p6, 3s2, 3p6. So how many total electrons here? 6 plus 4, 10, 10 plus 2, 12 plus 6, 18. Can you figure it out? This one is 10 and this one is 18. So when you write the ion configuration, can you see some similarity between the ion configuration and the noble gases? This is what is actually happening when you see a reaction. When the chemicals undergo a reaction, during a reaction, atoms become ions because they have the most stable noble gas configuration. So this one corresponds to which one? Neon, right? And this one corresponds to, look in the periodic table, where is that 18 coming from? Isn't it a noble gas? Argon? Yes. So we can write configuration for potassium, and you can see the potassium ion, I mean. So you can see that that will correspond to another noble gas, and this one also will correspond to, after writing the electron configuration, you can see the noble gas configuration. That is why it is forming ions, to get that stable noble gas configuration. Okay, therefore we can use the noble gas notation to write a configuration as shorthand or condensed form. Recall, the configuration for sodium is 1s2, 2s2, 2p6, 3s1. If we consider the valence electron 3s1 separated from the core electron, which is inner electron. Core electron means the inner electrons. We can write the electron configuration as Ne, that is a noble gas, because that corresponds to 10 electrons corresponds to neon, and 3s1. Okay, so the abbreviated form will be Ne in parenthesis, and then we will write 3s1. So it is very easy if you practice the shorthand representation. You don't have to write all the expanded form. Valence electrons are this one, 3s1, and these are the core electrons. Okay, let us try another example with the magnesium. What is the electron configuration for neon? 1s2, 2s2, 2p6. What is the electron configuration for magnesium? 1s2, 2s2, 2p6, 3s2. What do both electron configuration have in common? I can see that 1s2, 2s2, 2p6, 1s2, 2s2, 2p6. That is common, right? So that corresponds to the configuration for neon. So using neon's configuration and then adding magnesium's extra electrons, we can get the noble gas configuration as 1s2, 2s2, 2p6. That changes to noble gas configuration Ne in parenthesis and then 3s2, because this Ne configuration is same as the core configuration, core electron configuration here for magnesium. So for writing the electron configuration using noble gas, what we have to do is, it's simple. If we are writing the noble gas configuration for the second period, pick the noble gas from the first period and then continue until you reach that element. For example, if you're writing for beryllium, you will write helium in bracket and then follow from here. This is, you can see 2s2. So we will stop there. So helium 2s2. And now if you want to write anything from the third period, pick the noble gas from the second period, neon, and write the rest of it. It goes on. So if you are writing for this one, this row, you pick the noble gas from the top. This row, pick the xenon. So it is written here, helium, neon, argon, krypton, xenon, and radon. You can see that when you use that row, pick the one above it. Okay, that's the way. Let's see an example. Now, suppose we had to write the electron configuration for rubidium. Where is rubidium? Yeah, here it is in the first group, and 1, 2, 3, 4, fifth period. Since it is fifth period, I have to pick a noble gas from the fourth period, which is krypton, and I have to continue. So this one will be 5s1. So in bracket, you can put krypton and you can write 5s1. Another example, let's say calcium. Calcium is in the fourth period. I have to pick a noble gas from third period, which is argon, and then continue. This is 4s1, 4s2. So I have to stop 4s2. I don't have to write 4s1 because it is not completely filled. And we are here 4s2. So I will just write for calcium 4s2. Another example, if you want to write for titanium, we will go and pick again argon, right? And then we have to continue from here. I don't have to write 4s1, but I have to write 4s2 because it's a completely filled. And then I will write 4s2 and it will be 3d2. So that's the way you have to write for titanium. Okay, so you can pick any other element and you can practice like that. And let's practice more questions. That's it about shorthand representation.